Hi, my name's Ben, and today I'm going to be looking at a rock kit with you guys. This is specifically on the layers of the Earth. So if you want to check out this little diagram here, it shows the different layers of the Earth, not quite to scale, but it's good to just get a general idea of what we're talking about and how deep in the Earth this stuff goes. So we're going to start off with the crust, and if we move over to these two samples here, we have our granite. Now, granite was what most of the crust on the continents is made of. It's a fairly low density rock compared to the other stuff that we have on the table here. And it's mostly formed in magma chambers underground where the rock crystallizes very slowly. On the other hand, we have our basalt. This is a volcanic basalt, and as the name suggests, it's extruded from volcanoes. And it cools a lot quicker, so the crystals are much smaller. And most of the crust underneath the ocean is actually made of this basalt. It's actually very thin there, whereas the crust on the continents can be like 70 kilometers thick. It's usually only about 6 kilometers thick under the ocean. So if we go a little deeper, this is mantle material. This rock that's green right here is called peridotite, and it is found inside the mantle of the Earth. It's what most of it's made of. And believe it or not, even though the temperatures in the mantle are extremely hot enough to melt olivine, which is the main mineral this is made of, the pressures there are so intense that it prevents it from melting and it's still solid. When it comes up as a magma or a lava, the release of pressure actually causes it to melt. It's called adiabatic decompression, but yeah. Moving on. This is a chunk of an iron meteorite, and the core of our planet has two parts. It's got an outer core and an inner core. The outer core is made of a liquid iron with a little bit of nickel in it. The inner core is iron and nickel, but it's solid because of the pressure that's down there. And the reason that I have a meteorite here is because a lot of the planets that were forming in our early solar system 3.5 billion years ago, 4.5 billion years ago. They also had iron nickel cores just like Earth, but they got broken up by gravity of larger planets like Jupiter, or they suffered impacts from other planets. And the cores of those planets, the iron nickel cores, are preserved still as iron meteorites, which is pretty cool. And so those are our layers of the Earth. Thanks for watching.